Hello, AP Stats. In this video, I'm going to cover Chapter 4 in our review series. So this was all about experimentation and observational studies and sampling. So good sampling techniques are unbiased samples. So systematic random sample, that's where you have a random starting point and then you go every nth individual after that. Simple random sample, each individual and each group of individuals has an equal chance for selection. That's the HAP method. That's using a random number table. Stratified random sample. That's where you separate the population into different strata that are similar and then choose a simple random sample of each. So if we split the high school into 10th, 11th, and 12th graders, they're all similar within those strata. And then I randomly sample some of 10th grade, some of 11th grade, some of 12th grade, proportional to the overall amount. So if I know that 20% of the school is 10th graders, 30% 11th graders, and 50% seniors, in my sample, I'd want to sample the same proportion. Cluster sample. You're first going to separate the population into mini populations or clusters, and then randomly sample, then do a simple random sample of those clusters. So if I end up with 5 clusters, I'm going to randomly select 2. Say I end up with cluster 1 and 4, then I'm going to sample everyone in those clusters, every single one of those individuals. It would be like PE classes. They have 10th, 11th, and 12th graders in there, so they're mini populations. I randomly select one PE class and survey all of the students in there. We did the Justin Timberlake question earlier in the year where we were talking about how much people enjoyed his concert depending on where they sat. So if we have these 16 seats and say this is the stage up here, a simple random sample would be any 4 of these numbers. Could be all in the front, all in the back, all in the left, any 4. Stratified, we're going to select 1 from each row. So we're guaranteeing we're getting people close to the stage and further away. Cluster, we're randomly going to select one of these columns and take all 4 seats from that column, the left, the middle, or the right. Poor sampling techniques would be voluntary response sample where somebody chooses to be part of the sample. Call-in poll, any online poll, Wegmans leave your opinion kind of thing, or any store. Convenient sample is bad. You're just choosing people who are convenient. I sample my classes. Sampling error occurs if you have like undercoverage where your sample is not representative of your population, or your something about the act of choosing the sample. Non-sampling error is when you choose the sample, but then afterwards there's issues. So non-response bias. This is different than voluntary response bias because you've chosen the sample and now people are choosing to not be, you've chosen the sample, but people either don't respond or you can't reach them. Response bias, anything done to influence the responses. We talked about the Boy Scout question in class this year where he was wearing his uniform and going around asking if people supported the Boy Scouts. Response bias can include wording bias. If I ask you, do you like AP statistics? That would be response bias because I'm asking you. Wording bias would be like, an example would be like, do you support the president versus do you support a specific name, like whoever the president is at that point. Observational study, where you're just observing individuals and measuring variables, where we have 2 different types. We have the retrospective, which is using past data, and prospective, which is tracking individuals into the future. Whereas an experiment, you're imposing a treatment and it can show causation. All right, so building on experiments a little bit more, we have experimental units or subjects. Those are the individuals on which the experiment's done. The treatments is what you're applying to those subjects. And the factors are the explanatory variables. What are you controlling in the experiment? So there's 4 principles of experimental design. Control. Why? You want to control the confounding variables to make sure the only difference between your treatment groups is whatever you're testing, that factor. Randomization, we use random assignment. Replication, so we can have a larger sample size within each treatment group. And comparison, we have to have at least 2 treatment groups. Block design, where you separate the subjects into blocks based on some similar characteristic, grade level, age, and then randomly assign the treatments within the blocks. So if I think men and women are going to respond differently to a certain kind of aspirin, I would do something like this. I would block the men and women, say there's 60 men, 40 women, and then I'm going to randomly assign half the men and half the women to get the aspirin and get the placebo, and then within the blocks compare the pain relief. Sometimes they'll ask you to randomly assign, describe that process. You could use the HAT method. You could use a random number generator. This example, I just went through the HAT method. So you're going to write the men's names on identical slips of paper. You're going to put those 60 names into a hat. You're going to mix them up, and you're going to pull out names one at a time. The first 30 are going to receive aspirin, and the remaining 30 are going to get the placebo. Scope of inference, like what can we conclude? Can we conclude to a larger population? Can we conclude cause and effect? And it just comes down to how the way randomness was used. If you have a random sample, we can generalize the results to the larger population from which the sample was taken. And if we have an experiment that has a random assignment, then we can conclude cause and effect. So other things in here are like blind, double blind, matched pairs experiment. This doesn't cover every little detail, but hopefully that gives you a pretty good overview of chapter 4.